Hello, my little mathematicians. I'm going to help you go through the 11.1 through 11.3 study guide. Are you ready? Okay, as usual, always feel free to pause the video, give it a try yourself first, and then unpause it and follow along with us and check your answer. And you can speed up, slow down, rewind, whatever you feel like doing. Okay, number 1, what is the solution to p divided by 4 equals 12? So they want to know what's the answer. Okay, so let's substitute it in. 3 divided by 4 equals 12. That doesn't even make sense. 3/4 equals 12. No, it doesn't. Okay, 48 divided by 4 equals 12. Well, 48 divided by 4 is 12. So 12 equals 12 is a true statement, which means P is probably 48. Okay, or 1/3 divided by 4 equals 12. I hope you can see that that does not make sense. Okay, 8 divided by 4 equals 12. Well, 8 divided by 4 is 2, and you get 2 equals 12. No, it does not. So that was not a solution. Now, technically, I know you could have just solved this. P divided by 4 equals 12. To solve for P, you would do the inverse of dividing, which is multiplying by 4 to get those to cancel out. Because when you cross cancel, these become a 1 and a 1, and you have 1 times P, which is just P, and P over 1 is P. But whatever you do to one side, you got to do to the other. So since I multiplied this side by 4 to get it to cancel with that 4, I need to multiply this side by 4. And 4 times 12 is 48. So you're like, well, then why did you do all the others? Because I just wanted to check what if it was a check all that apply. Okay, but the answer was 48. B. All right, number 2 says what value of x makes this equation true? Please take note that on our quiz, we're going to say if you don't show the undoing step for all the problems where you're supposed to solve, no matter what score you get, we're going to take off like 2 to 3 points. All right, so please, 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 please show the undoing step, okay? I know that you can do these in your head, but practice showing the undoing step. So draw a line down from your equal sign. And how do you get x by itself? You do the inverse of plus 7, which is minus 7. Whatever you do to one side, you got to do to the other. We did that because these cancel. 7 minus 7 is 0. Now you have x equals, well, what's 12 minus 7? It's 5. We're practicing doing this because later on, especially next year, it's going to get trickier. And it's really going to make a difference that you do them right because we're going to involve integers and negatives and positives and everything. It's going to get really tricky. So we want to practice doing the inverse step now so that once they get hard, you know what to do. Okay, and we gave you easy numbers so that you could focus on doing the undoing step. I know you can do it in your head, but again, what we're really grading you on is practicing doing the undoing step and showing your work correctly so that when they get harder, that becomes like second nature to you. All right, let's go ahead and substitute in what we think the answer is, a 5. We think x is 5, so substitute it in. 5 plus 7 equals 12. Well, 5 plus 7 is 12 when you simplify the left. Bring down the equals 12. Since that ends with a true statement, you know for sure that x equals 5 was the right answer. So I'm going to put x equals 5 up here. Again, I'm practicing showing my undoing step and checking my work because later on, once they get harder, you want to be able to know how to double check yourself that you did it correctly. All right. Okay, number 3, same thing. Draw a line down from your equal sign. Do the inverse to get m by itself. Well, I need to get rid of this positive 12, so the inverse of adding 12 is to subtract 12, because then those cancel and you just have m. But whatever you do to one side, you have to do to the other. 13 minus 12 is 1. Okay, so I think m is 1. And you're like, wait a minute, I can't write that on the line. Why? Because if you actually read the directions, it says, is m equals 22 a solution to this equation? Neatly show the steps to the correct solution. No, the answer was 1. So no, 22 was not the solution. Okay, and if you were to the other way, rather than solving it, you could have substituted in what they think it is. 13 equals, well, m is 22 plus 12. Okay, and when you simplify 22 plus 12 Don't be afraid to work that out off to the side. Okay, you get 34 equals 13. Clearly, that's not a true statement, so you would again get no. So you could either substitute in what they think the answer is and see if it makes a true or untrue statement. If it was true, then yes, that would be the right answer. Essentially, when they're asking it like this is you doing the checking part. You're substituting it in and saying, hey, did they get the right answer? Okay, or you can try to solve it and see if that's the same thing that they got. Either way. Okay, number 4 says, what value of Q makes this equation true? Neatly show the steps to the correct solution. Now for this one, I want us to rewrite it as a fraction. Okay, Q divided by 2 equals 14. Because it's just easier to show your work this way. When you have something being divided, I'm going to do the inverse of dividing, which is to multiply, so that now those cross cancel out to become 1, and now you have 1 times Q, which is just Q. Whatever you do to one side, you have to do to the other. Since I multiplied it by 2, multiply this side by 2 as well. And 14 times 2 is 28. So I think Q is 28. So then to check your work, okay, write your original equation. Q divided by 2 equals 14. I think Q is 28. And 2 goes into 2 once. 2 goes into 8 4 times. Bring down your equals 14. Yes, that is a true statement. So with confidence, you know that that is the right answer. Q equals 28. Number 5 says, what is the solution to this equation? Neatly show the steps. 13a equals 65. When you have a number touching a variable, that means they're being multiplied. The inverse of multiplying is to divide by that number. When you divide something by itself, you get 1, right? 13 divided by 13 is 1. So 1 times a is just a. Now I got a by itself, but whatever you do to one side, you have to do to the other. 65 divided by 13. Well, I know that 12 times 5 is 60, so 1 more would give you 65. So it's 13 times 5. And that might be one, I kind of guessed my way through it. For sure, you would probably want to check yourself, right? 13a equals 65. So actually work out 13 times 5 and double check that it for sure equals 65. And you get 65 equals 65, a true statement. So you know, yes, A was 5. When you finish your test, always double check that you wrote in what the correct answer was. Okay, you like X is 5, yes. And then M was 1. Wait, why does it not say M is 1? Oh, because they were asking me, is 22 the answer? No, it was 1. Okay, Q is 28. A is 5. This right here is your checking. 65 is not the answer. That was just to see that it ended with a true statement, like 65 equals 65, 14 equals 14, 12 equals 12. That's a true statement. So we knew 5, 28, and 5 were the right answers. This one ended with an untrue statement. So we knew that 22 was not the right answer. All right. I think we've killed that, right? Let's move on. Number 6 says, what value of H is a solution to this equation? Draw a line down from your equal sign. What's the inverse of subtracting? It's adding. So add 7 to get these to cancel. 7 minus 7 is 0. Now H is by itself, but whatever you do to one side, you got it. You have to do to the other. So 12, carry the 1, 1 and 1 make 2. So I think H equals 22. Let's just double check because, I want 100% on my test, right? Let's always double check that we did it right. Okay, it's your built-in check. H is 22 minus 7 equals 15. Let's see if we get 15. 22 minus 7, borrow. 12 minus 7 is 5. Bring down the 1. So this way you don't kick yourself later if you made a simple math error. Okay, hopefully you won't make a math error twice. So by you checking it, hopefully you'll catch yourself if you did. So if you end with an untrue statement, erase it and try the problem again. That's why we're checking. Okay, number 7 says a plant grows taller, increasing from 17 inches to 42 inches. how much did the plant grow by? Write an equation using x to represent the increase in height. And again, you're not solving it, you're just writing the equation. Okay. So why don't you try this yourself, okay? Pause video, try it. Now unpause and you're back with us. Okay, now if the first equation you didn't do, it's okay. There's several options. I would think of it as you start at 42 and then you grow some. And so to find x, I would subtract, right, by how much it grew right here. And you're like, wait, it said that it increased from 17 inches to 42 inches. So if you find the difference by how much it started at, it started at 17 and then what it ended at, that difference tells me by how much it grew. And then vice versa, you could have said, okay, so if it ended at this, however much it grew by should give you the starting point. Okay, a lot of other people probably see it these ways. You take that it started at 17. Then however much it grew by, which we don't know, equals its ending point. That's probably the most common one that I would have done. Or you could have said however much it grows by plus what it started at equals its ending height. All of these are equations that would work. The only one that I don't really particularly like is this one right here, 42 minus x equals 17. Because if we were to solve this, you don't actually know how to solve it when the variable is negative. So when you're writing an equation, try to avoid having the variable be negative if possible. Okay, just a helpful hint. But if you don't have to solve it and you just have to write the equation, all of these would actually work. Okay. All right, let's go ahead and turn the page. The next one says 7.5 inches are cut from Elia's hair. Her hair is now 11 inches long. Write an equation using x to represent how long her hair was before getting cut. So x was how long her hair was before getting cut. Okay, so it started, and I always like using the one where you start. Okay, so it starts as x. Then 7.5 inches are cut from it. So I'm going to subtract, because you cut away 7.5 inches. And her hair is now equal to 11 inches long. That is the equation. Okay, I like that one the best. You also could have done how long her hair is plus how much was cut away equals the length that it started as. Okay, that works too. To solve this one, you would add 7.5 to get x by itself, add it to the other side, and you get 11 plus 7.5, which, hey, that's what this one's saying too, right? Okay, but it didn't ask you to solve. It just asked for the equation. So either one of those would work. Number 9 says there are 90 chocolates in a box. I feel like Forrest Gump. If everyone at the party gets 6 chocolates, there won't be any chocolates left over. How many people are at the party? Write an equation to represent the situation using x to stand for the number of people at the party. So I would do, this is how much I have. I'm going to divide it by how much everyone gets, and that equals how many people there were. Okay. Or another way that you could do it is, okay, everybody gets this many. We don't know how many people are at the party, but I know that I have this many total chocolates. Okay, so however many each person's getting, 6 times how many people are attending, equals the total number I have to give away. Both of those are good equations to solve. Some of you guys are probably like, yeah, well, you know what? This way works too, Miss Love. You could do how much you have divided by how many people there are, and that would equal how much everyone gets. True. That equation does work. But just like we don't want variables to be negative, we also don't particularly like variables at the bottom, because this is representing 1 over x, and you don't want 1 over x. You want just x. So try not to have the variable in the bottom. okay? Because it wants us to solve it. So which one do you want to do? Let's do this one. 90 over 6 equals x. So to solve for x, simplify. 90 divided by 6. Let's divide it in. Well, 6 goes into 9 once. Subtract that, you get 3. Bring down the 0. 6 goes into 30 5 times. So 90 divided by 6 is 15, which means there was 15 guests at the party. Or if you did it this way, 6x equals 90. To get x by itself, you would do the inverse of multiplying to get x by itself. Okay, well, the inverse of multiplying is to divide. Whatever you do to one side, do to the other. The reason I did that is because anything divided by itself is 1. 6 divided by 6 is 1. So you have 1 times x or just x. Now I have x by itself. 90 divided by 6, we already said, was 15. Okay, those are either way that you could have solved it depending upon which equation you used. Now some of you are like, why didn't you say I could do it that way? Because let me just show you that this is a bad equation to use if you had to use it to solve. Your first step you'd have to do is to get x out of the denominator because you can't have x down there. So you'd multiply here to get it up. And you're like, but they cancel out. Yeah, true, they cancel. So now it's out of the denominator and you have those become 1. 1 times 90 is 90. And whatever you do to one side, you do to the other. I multiplied by x, so multiply by x here. And you get 6x equals 90. Hey, that's the equation we did here. So then I'd have to solve for x, divide by 6, and you get 15 equals x. See how it adds in an extra step, and that's just super irritating. And you'd have to remember to do that extra step to bring x up. So again, try to avoid having your variable in the denominator. All right, our next one says which equation has a solution of r equals 4? Always double check them all because what if there's multiple ones? Okay, this says 4 divided by 2 equals 8. Well, 4 divided by 2 is 2. Does 2 equal 8? No. Okay, 4 times 4, because that's what they think r is, equals 16. Well, 4 times 4 is 16. 16 equals 16 is a true statement. So yes, 4 would work. Okay, 8 equals, they think it's 4 divided by 8. And if you simplify this, reduce it by 4, 4 divided by 4 is 1. 8 divided by 4 is 2. So you get 1/2 equals 8. No, it does not. Okay, and then the last one, 2 times 4 equals 6. Well, 2 times 4 is 8. 8 does not equal 6, so that one didn't work either. There was only one solution. And notice how it kind of said which equation has a solution of r equals 4. It didn't say which equations, and it didn't say check all that apply. That's your hint that usually there's only one. But some people like to solve all of them out just to double check. In case, what if they made a mistake on one and rushed to their answer? If they had 2 and there's only supposed to be one correct answer, when you go to click on it, there might, it would erase the other one. And so then it only allowed you to answer one answer. So then you would know, only one of them is right. Let's double check. Okay. If it's check all that apply, it would say something like this one, number 12, circle all that are true. Okay. And then when you click on one, it doesn't erase another choice. Just some helpful test-taking strategies for you. Okay, this one says which equation is true for w equals 5. So let's replace w with 5 for all of these. 7 times 5 is 75. Well, 7 times 5 is 35. 35 does not equal 75, so no. 78 minus 5 equals 83. Well, 78 minus 5, I know it seems silly, but write it out off to the side because I have people put this as true. And if they rushed, they might have put 83 equals 83. Yeah. Okay, no, if you show it, no, it's 73 equals 83, which is not true, making that not true right there. Okay, and then 55 divided by 5 equals 10. Well, 55 divided by 5 is 11. 11 does not equal 10, so that one didn't work either. And before you just jump to this one being right, actually work it out because what if you made a mistake? Okay, 2 times 5 equals 10. 2 times 5 is 10. 10 equals 10 is a true statement. We lucked out because that one was true. Okay, now for our last one. It says which equation has a solution of 9? So let's replace 9 with x. 9 minus 6 equals 15. Well, 9 minus 6 is 3. Does 3 equal 15? No. So A is not one of the solutions or one of the equations with 9 as a solution. Okay, 9 plus 6 equals 15. Well, 9 plus 6 is 15. That equals a true statement. So yes, that one would work. 22 equals 13 plus 9. Let's go ahead and add 13 plus 9. And you get 22. 22 equals 22 is a true statement. So yes, C would work as well. 3 times, because 3 next to a number means multiply. So replace it with a 9. Please don't use an X to represent it. Please don't just put it next to each other. Put it in parentheses. This is showing 3 times 9 equals 27. 3 times 9 is 27. That ends in a true statement when I bring this side down. So yes, that one is a solution as well. All right. Hopefully you did pretty well on these. If not, flip back through your notes and homework assignments of ones that we skipped and give some others a try. You've got this.